Now next is law of conservation of linear momentum. As we know that the body remains at rest or continues to move with a uniform velocity if no external force is acting on it. This is first law of motion. And second law of motion is the rate of change of momentum of a body is proportional to the force acting on it. So here you can see the force acting on a body, force is equal to rate of change of momentum, and momentum is equal to mass into velocity. So we have written this in the bracket. And if there is no external force, that is force will remain constant, force will remain zero, then rate of change of momentum will be zero, other side will be zero. And if we remove the time interval, then p is equal to mass into velocity, momentum is equal to mass into velocity, it will remain constant. As we know that the action and reaction being equal and opposite, the force of action and reaction is equal and opposite. So force on particle 1 by the particle 2 is equal to the force on particle 2 by the particle 1. That, as we know, in the same way we can write F12 is equal to dp2 by dt. In place of dp2 we will write m2 v2, and as we know mass is constant, so we will write mass here and dp2 by dt. For F21, force on particle 2 by particle 1 is equal to dp1 by dt is equal to d by dt. P1 is equal to m1 v1, mass will remain constant m1 dv1 by dt. So we will put all this second equation in equation first. F12 is equal to minus F21. We can also write F12 plus F21 is equal to 0. So put all the quantity of F12 and F21 in this dp1 by dt, this, and dp2 by dt. And in this we will take common the time interval d by dt, and p1 plus p2 in the inside of bracket, this will remain all the 0. So if we remove the time interval, then we can write p1 plus p2 is equal to constant, or m1 v1 plus m2 v2 is equal to constant. This is all about law of conservation of linear momentum.